Hi, this is Paul, and today I will be walking through the day 5, which is about finding which strings are nice and which are not, and they are defined in a set of rules, which is directly the first rule is for a nice string. It means that the string has to have at least three vowels. Um, what else? Okay, so it has to have at least um, a pair of um, some kind of a letter, and the only rule that it should not have is I'm sorry, uh, that it should not contain some specific substrings in that string. That is A B C D P Q and X Y. So let's start working on that. I've already got the data input and let's save it. Second. So it's day 5, and as usual, um, let's work on day 5 part 1. So analyzing the thing, we have three rules and we can probably define them somehow. So yes, I mean, uh, since every line of this file has a specific string which we analyze, we can simply um, read line by line and calculate the result. I probably forgot to mention what the result is. The first part asks for how many strings are there, how many nice strings are there which follow these three rules. So let's open the file and just read it. So in this case, we just get a simple line, but what we want to have before reading everything, I mean, definitely a good thing just before reading is to set what we're searching for, is to define these rules. So first of all, let's call it simply rules, or rule 1 for this matter. Having the array of vowels that's defined there. Generally, we can find a better way for defining this, but for now, let's just use it this way. Right, so the second one is just finding two in a row. So I don't know, like it's it's probably a good idea to use lambdas for this task, but let's not do that for the moment. Let's just do a simple, straightforward approach, and later I will show you the solutions that you can use with lambdas. So rule two second two same letters in a row, and rule 3 is AB, CD, PQ, and XY. Okay, so when we start reading the string, we can start by checking the rule 3, because like if the string contains any of these substrings, the A, B, or C, D, P, Q, or X, Y, we can stop counting everything. Stop the latter checks and just quit. So also we need like nice count. We set this up so if rule 3 in line, which means that if yeah, so that makes sense. If any, second. Oh no, then it's a bit different. If let's just use line in O F. That's rule line. We'll see if this works out or not. So let's just say rule 3 count. Let's just count if this works out. If not, then not. Yes, so it uses the approach of using a string rather than so let me think about it. How should I approach this? Basically, what we want to do is to check all of these values in rule 3 if they exist in line string. So what I try to use the any is apparently that it just checks a different thing. Yeah, it just checks. We can like set a function for that probably. I've got a bit blocked memory currently, but I think I'll just figure it out later when I'll start working on the Lambda solutions. Check string probably. So substring array and the string if string. So we use this for for substring and substring array. So we define ourselves contains true. No, contains false. If substring string contains true, return contains. I mean, I can simply write return true here, but I think that it's a good practice to always return some kind of value instead of return none at this point. So let's have a look. '84 that do not follow the first rule, so that's great. If not, so at this point we're just looking for the nice count. So we care about the first row, then we care about the second. We can actually make it one line, I mean one conditional, but it will become a quite big one and quite difficult to look through. So I mean another bad thing that I'll be using that it's that I'll be using the I believe conditional pyramid. That's how it's called. What means that I just tab, I mean shift to the right, and the code starts to be like really hard to look at because by shifting by like, let's say 4 spaces and like you do 20 shifts, so it's 80 spaces already, which is 80 symbols shifted, and the casual recommended the line width is about 80 spaces. I mean, nowadays it's probably 100 or 120, but generally it's not helping in readability either. But for this case, we just have three rules, so it's three ifs, and the shift is only by 12 characters. So I don't think that this will harm too much. But yes, for the straightforward, we're just looking at this quite simply. So let's look at, let's say, rule 1, which is about finding the amounts of letters. So let's just do, I don't know, I mean, let me think. Let's see. Python. Yeah, that's the thing that we're searching for. Definitely. How many times? Count. Yes. In a sense, that is what we're searching for. Let's just look at the problem again. It contains at least 3 vowels. Okay, so let's just check rule 3, and check rule 2. Rule 2, as in we have the character array and we have a string. So for just call it token, I suppose. Okay, so we go through all of the characters and we check for at least 3 vowels. Okay. Count vowels 0. So vowels plus equals count. How many? Yeah. So in string, how many this specific character there is, and what we return is if it's at least 3. Okay, so return vowels is more or equal to 3. So let's define the rule 3. We can also change this to nice count already. If check rule 2 rule. So that's not rule 2, that's rule 1. Rule 1 line. And lastly we check for rule 2 line. If all these checks match, we just increment by 1 the nice count. So let's just use contains false, our last character. I mean, last character is none for character 1. The last dash So what we do here, we just predefine last character to none, and then just check if last character is already defined. If it is, this is the first character in this case. After that, this part is never reached. There's only this part that is reached, and we only check if if this character is equal to last character. If it is, then we just say contains true, and we return contains, and that's it. And this should probably return us 253, which is the wrong answer, and we can start working through why did this become a wrong answer. Okay, so does not contain the strings. Let's look at it. Maybe I've made some errors in my logic, so this is quite probable. Okay, so let's start with rule 3. We work through the substring array, which is a, b, c, d, p, q, and x, y. And we check if this specific substring is in our selected string. If it is, then let's return true. So at this point it will always dodge it. I believe that this should be the case. It does not contain, even if they are part of one of the other. Okay, I don't really care about that requirements at this point. So this looks quite okay. Let's look at the rule 2. We go. Oh, so this is the rule 2, isn't it? Yeah, we apparently checked the rule 1 first, but whatever. We can try printing. That's interesting. Let me see. String count. Okay, we can print. Probably just print the vowels. It really depends. We could also print the string. So this has 3 of them, and this sort of works, I think. That's interesting. I'm a bit confused. Why is it not working for this one? Check rule 2, check rule 1. You know what? I think that probably the straightforward way, by using these functions, might make some kind of errors. Let's simply use lambdas for this, and let me continue in a bit. Hey, so let's continue on with remaking the whole part 1 into lambdas. So lambdas are useful for one-liners, and generally they are the same as functions, but they're a good way to automate things. So let's remake the rule 1 by changing it into a lambda expression. Let's use a line. So what we want to know is, for this specific function, we can take it up just to have a better look. We want to go through all the array, so for character in A, E, I, O, because it has like a defined already list. So we go through these, all of these values. We want to count how many of them does the line have. So we want to have an array of these an array of how many each of these has. Although this array doesn't have the specific bindings, it means that it will have, um, let's say for some kind of string which has five a's, it will have five in the first index, but it will not explicitly say that a is like five. I mean that you can find a five times. So this array, we need to sum it up, which is we will add all the values in that counting array together, and finally check if it's equal or larger to 3. So that's this function. Let's go with the second rule. So the second rule is just looking for 2 in a row. So let's go with lambda again with a line. So we don't need anything to look at. I mean, we don't need any predefined arrays for this. I don't think that it's really beneficial to use a predefined array for this specific task anyway. So what we want to do is to go through all the characters in the line and check if this character is equal to the previous character, and if not, then just say that it's not. That's pretty easy, I don't know. So this task requires an additional character, so for lambdas it might look a bit difficult, but it's doable, definitely doable. So let's start by starting by the first cycle, for cycle. We go through all of these characters, and we have to have a check. Whereas, let me think how to process this information. Yeah, so we just need to check this character with the previous character if the previous character exists. That is, that we do, let me do a simple slight change. We enumerate so that we can get an index to previous, the index to previous or forthcoming characters. So at this point we just check if we can just simply check character is equal to line I plus 1. So we have to also do if line plus 1 if I is below the length of line. Why do we use this if? Is because that we don't want to go out of array size, having a higher index. Sorry. Yeah, so that's definitely what I'm looking for. Puts everything into an array. So we can like double check what we get from this actually. So let's use a test string, which is A, B, C, D, E, F, double F, G, H, I, J. And print the rule to with this specific test string, and just exit at this point. Okay. Oops. String index out of range. It means that I've done some logical errors at this point, and let's just work it through. So it gives an array of false, 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 which is quite the same way that we had. And there's one true, which is these two F's. So that's good, but we don't need this array. We need only to see if there's any true that's already there. So the function that I've looked before, Python any function, which is inbuilt one, it does that exactly what we're looking for. That it goes through all the elements, and if the element is true or it is defined, we get the answer true. So we simply wrap it up with any. And last but not least is the negative. I mean the rule which defines if it's a bad one, because the previous ones were necessary to find the result if any of the first two rules goes true, it means that the string is definitely a good one. But for this one, we need to see if our function, our string does not contain that. So that's a bit, let's say, negative check. So let's again look through the whole line. And what we want to have is to, let's just start and expand from the point that we understand. So for, alright, so we have substring in this A, B, C, D, P, Q, and X, Y array. Check if we're not missing anything. Yeah, it's only 4 substrings. And so what we do for them is we simply want to check if this specific substring is in the line. So we do substring in line, and we also need to get let's also add xy here and do rule 3 testing. So we will get some kind of array of results, and let's see what the results are. Not callable. One second. Rule 3. Yes, so we get true, true, false, true, which is quite interesting, which means that we have AB, which is here, we have CD, which is here, PQ, which we don't have, which means that it's false, and we have XY. So at this point we have to get any, and any returns true if any of these sub elements are true. But we don't need to have any, we need to have not any. So it's like inverse. Have we saved it? Definitely true. Yeah, so now it says that the rule 3 is not fulfilled. That means it's false. So let's delete all the unnecessary things that we have inside. Leave the rules as they are. Delete this. Start reading the file and simply do if rule 1 and rule 2 with the line and rule 3 with the line. We only then increment the ice count. So that's in a way more easier to read at this point, but it might be difficult to read this kind of string. But then again, it's a simple solution for this, and lambdas are used for this kind of simple solutions. I mean, it's not some kind of state-based function which has to have several states or several checks and so on. So it's 238, and the answer is 238. So let's jump into the part 2, and part 2 says that the method on defining what kind of strings are good ones, the nice ones, was changed. So now the following rules are to: it has to contain a pair of any two letters that appear at least twice in the string without overlapping, which means that, as we can see, XY is good because the XY substring appears 2 times, and that's why it is a good string at this point. But then again, we need to see that it does not overlap. And the other rule is that it contains at least one letter which repeats with exactly one letter between them. Which, well, let's put it it's in a bit different way. We have to find that the letter has this is the same in by shifting the index by 2, which means that we can really ignore this part. It doesn't really matter for this one. So let's open day 2, part 2, day 5, part 2. Since we started working with lambdas on these rules, let's try completing the same thing in part 2. Although we'll see if this works out or not. So let's just use a lambda line pass. Rule 2 is also lambda line pass. Nice count, yes, and with opening the file, we use the same. I can actually just copy this thing because it doesn't have to be that difficult, to be honest. Okay, so we have these 2 rules. Let me check. It contains at least one letter. Okay, so that's only 2 rules. Okay, so let's start with rule 1. Okay, so we need to take a substring in that string, and we need to find how many times does it occur. What this means that there's also this additional thing that we have to have it not overlapped by, let's say, having 3 letters in a row, which makes it overlapped. This means that we have to understand the mechanics under the string itself. Since, let's say, if we're looking for this kind of substring, we need to somehow remove the current looked substring, so we'll just do a simple search, which will be based on, it will be based on simply removing that part from the search string. I don't know, yeah, that's definitely how I think I'll do it. So let's do the simple simply do, I don't know, range length of the line. So we go from 0 to some specific number, which is the length of the line, -1. It goes through all the characters in the line string, and what we want to do is just to take another substring, and by taking the another substring, we want to another character. It takes 2 characters. We want to read for a range which is not in the not in it. So it becomes quite difficult to solve this by lambdas. If somebody can see this through, that's definitely a good one, but let's not use lambdas for this one. So let's just define the rule 1 with line And so let's go through all of the characters. I mean, I in range. X range probably would be better. Line. Yes, so we have substring, which is which is line I to I plus 1. We also have to have a check on that, to be honest. Questionable if we can. Maybe we can have some kind of approach where we get a pair in the cycle already, so that would be useful, to be honest. But I don't have any ideas on that so far. So let's do a check if I plus 1 is smaller than the length of the line. We go this path, and I mean it will just stop when it's higher. I mean it won't stop, it will just not do anything in the case if it's higher, and I mean that's the last iteration, so it will just quit. So we have this substring, but then we want to like use a temporary string, or I just call it temporary, which is line by replacing substring by removing it, or we can like replace it by simple 2 dashes. That is, when you think about it, if we have, let's say, an A, or is it like A, B, B? So C, D, let's say, and there's also this something like this. So, well, let's say that we're looking with this algorithm, and we look at the first two. Then we see that we don't have it. Then we look at the AA part. We also see that we don't have it. And when we look at AB, if it would remove this substring AB and leave no substitutes for it, then you can see that AB, by removing the previous AB, there's another that forms because of removing the substring inside of it. So that's why we need to add a double dash, or we can simply add a single dash, but it doesn't really matter. We can also, just for the case of using the same amount of symbols, we can simply use a single dash or something like that. So at this point we have this kind of string, and we want to simply do if substring in CMP, which is we have removed it and we have it, so how should I call the variable? Rule okay, I don't know, false, and simply rule okay is true at this point. Return rule okay. So yeah, this is a bit difficult there because there's 2 ifs and there's some additional work done on that, so that's a bit, I don't know. We could try rewriting this idea. Let's see, lambda line for I in X range, then line if I plus 1 is less than the length of the line. We'll only do this way, and what we do with this part is, yeah, we can probably do that. That's right. So, it might look a bit difficult to look at it at this point, but it's still doable. This is an line replace line I plus 1 by a dash. So, and this is any. So that's definitely a long one, but let's see if this works. Roll 1 lambda. What's wrong with it? Invalid syntax. Okay, so that's true. And let's see if it works out with the rule 1. The rule 1 was about having some kind of a string. So let's use these. Yeah, let's use this one. Test 1 is for testing the first pass. So print rule 1, test 1, and print rule 1 lambda the test 1 2. Right, we forgot the equal sign. False, false, which is what we're looking at, what we want to have. But then we want to have this to get both true and true. But it gets us false, false. I wonder why. Because like the rule 1 goes, the replace part might be a bit tricky, I suppose. Yes, the replace is a bit tricky indeed. So what we want to do is instead of I plus 1, yeah, that's probably what I'm looking for. I plus 1 is equal just to 2 dashes. So, it takes 2 places, so let's just add 2 dashes for this part. But this can be simplified in a sense because, yeah, that's not questionable if we can do that in the lambda. Okay, so that's pretty straightforward solution for that. We can probably also, that's a bit more lines to use, but still. So only one occurrence and only one occurrence. That's nice. And let's use the tricky part, which is, let's say, z x a b b and x 0. So at this part, it should always return false. But when we return, if we've already worked this through, so it doesn't even matter because if we remove, we get this. We should get this. Let's just see if it actually works. Well, hello there. How come? Is it actually failing? Well, that sucks. Let's see. Print. Oh boy. No, I'm not looking through this. Oh, wait. I don't get it. Wait, so I'm looking for a substring too. Why am I looking for one character, for fuck's sakes? Oh, that's stupid me. Good. Yeah, so I made a mistake, which was quite apparent, I suppose, but I didn't see that at first, so that sucks. We can remove this. Also rename this to a simpler form. Remove this. Right, so we can count, let's say, how, wait. Yeah, so at this point we're just counting the actual results that fill the rule 1. Rule 2 always returns true, so that's not a big problem. That's 129, which solely fulfill rule 1, so it means that the result should be either less or equal to this result. Let's see, yeah, it's 69, so we just need to set our second rule, and the result will probably go down by half, somewhere by half. So the second rule is, it's the jump. It's about having a higher step. This is actually similar, or at least same, to the rule 2 and here, which we had a step by 1, and we'll just have a step by 2. Which means that we have to check it by stepping a bit further, and that's it. And the result is 69. Yeah, so that's it for day 5, and thank you for watching.